Welcome to this session on blockchain development, guys. My name is Pavan Kumar, and I work as a full stack developer as well as tech manager here at Nonsblocks. And you can connect with me here at my portfolio link. So I have all my portfolio socials listed over there. You can connect with me anywhere you guys want. Okay, so moving on, the first thing is we'll discuss and talk about blockchain. So whenever you hear this term about blockchain, right? So what is the first thing that comes to your mind? Or even if you ask anybody around you, what is the first thing that comes to your mind? Well, the first thing that comes to your mind is like decentralized, immutability, all those stuff, right? So in reality, those things are features of blockchain. They're not exactly what a blockchain is made up of. Okay, the blockchain is nothing but a series of computers or a network of computers connected with each other. Okay, so you'll have like bunch of computers around the world, and they establish a network among them, and they communicate with each other. That's what blockchain is. Okay, and the mutability, the decentralization, all these things are features of blockchain. Okay, so again, so blockchain is nothing but a network of computers, and we refer to these computers as node. Okay, so we call them as node. Okay, and you can see we have connections in between them, and these connections are known as peer-to-peer connections. So they'll have one-to-one connection with all the computers. They can communicate with them. Okay, and this is really important. I'll come back to this later. So next thing is blockchain nodes. So you can see, you know this, what is blockchain node is. Now it's a computer, but how does this computer actually look like inside it? So it looks like something like this. So it's not like exact visualization, but in general, okay, obviously computers will have something else, but it's like a general visualization how it might look like, a blockchain node. So the blockchain node will be running a software. Okay, like if you take Ethereum, it will run Ethereum client software. If you take Bitcoin, it runs Bitcoin client software. Okay, and these softwares, right, which is running in that particular node, will contain all the list of blocks. And if you have, let's say, 100 nodes throughout the world, all those 100 nodes will have same amount of blocks. Okay, they'll have copy of every single block. And this is really important because this helps in validating. Okay, we'll learn about this validation in the mining session, okay, after a few slides. But for now, keep this in mind that all these blocks, all the blocks of blockchain, like whatever the blocks we have, will be present in all the nodes. Basically, all the nodes will have copy of the blocks. Okay, and what is this block that I'm talking about? How does that look like? Okay, if you take a deeper look into the blocks, it looks something like this. It will have a header and a transaction list. Basically, a node is a collection of blocks, and the block is a collection of transaction. That's in general. Okay, so let's say I send some like 10 tokens to you, right? That's a transaction, and that transaction will be included in this particular block. Okay, similarly, there can be multiple transactions throughout, like for 10 minutes there can be 10 transactions, right? All those 10 transactions will be included in this block, and then this block will be inside a node. Okay, that's how the general hierarchy is. Okay, and why is this block header necessary here? Because you'll have, like, let's say millions of blocks in a blockchain, right? And you need some way to identify each and every block, right? So if my transaction is in, let's say, block number 6, and right now at present we're in block number 1 million, so there are 1 million block, and if I want to trace my transaction back, I need to be able to backtrace it to block number 6, right? That's the reason why we have block header. This block header will work as identification for the block. So what does this block header contain? This block header contains, like, version. So what is the exact version of this block? So there can be software updates or block chain updates and everything, right? This will contain the number of the version and time mined, like when was this block created, basically the timestamp, and then the previous block hash. So in order to form a connection between each and every block, every new block that is created will have connection to the previous block. Okay, and then a target and nonce. So these are the numbers, the target difficulty number, and then the nonce. These are used for mining purposes. We'll talk about mining later, but remember this, the target and nonce. Okay, and the transaction below is nothing but a group of transaction. So every block will include a bunch of transaction inside. Okay, and coming to mining and consensus, before going to mining and consensus, do you guys have any questions on the basics of blockchain that we discussed till now? The three concepts: node and block and transaction. Do you guys have any question? I'm here in the chat. If you can just drop the chat if you guys want. Okay, feel free to drop a message anytime you guys want if you have any doubt. Okay, and coming to mining and consensus again, this is really important because right now we did learn about this hierarchy like node, blocks, and transaction. And you know that blockchain is public, right? Even if you can go to Bitcoin and do a transaction, you can go to Ethereum and do a transaction. So in order to do a transaction, you have to spend your money on that, right? You have to buy the crypto, the Ether or BTC, all these crypto. You have to spend your money on that. Or let's say you're transferring some asset like your papers or your certificates or anything. So you have to first trust that blockchain, right? It's not like just because people are saying, oh, go use this blockchain, you don't go there and then transfer your assets on that blockchain. First thing is you need to know whether you can trust this blockchain or not. So how can these public blockchain like Bitcoin, Ethereum, Polygon, all those other blockchain can establish a trust? How are they guarantee? How can they guarantee you that this blockchain is safe and you can trust us and then transfer your valuable asset on this particular blockchain? That is because of the consensus and mining. So what happens in mining? So mining is a process of creating a new block. Okay, that's a very simple. So whenever the new block is created, there is a process behind it, and we call that process as mining. Okay, we'll keep that aside for now. What is consensus here? Consensus in general, okay, in speaking in general terms, consensus is nothing but an agreement and a decision. Okay, so we are all in this meeting, right? So if I say something wrong, so all of you would disagree with that, right? And if I say something right, all of you would agree with that. So this disagreement and agreement, okay, or this process of disagreeing with something and agreeing with something is known as consensus in general, okay? And this applies in blockchain as well. So in blockchain, what happens is whenever a new block is created, right? Whenever a miner, when I say miner, it's not a person who's sitting behind a computer and doing it. It's just a software that creates a new block. Okay, we'll talk about how mining happens, but for now, mining creates a new block. Okay, and you cannot just add that block to the blockchain. That block should be validated. Okay, how does this validation happen? If you remember this session, blockchain node, you can see all these nodes contain duplicate blocks, like basically copy of the same block in all their nodes, right? This is why they contain the copy of the blocks. So what they do is they take that new block, they attach it to the existing blocks internally, and they'll see that if all the state or the data that in the blockchain is same or not. How do they do that? So let's say initially I had 100 bitcoins, okay, and I sent you 10 bitcoins. So now I have 90, you have 10, right? That's the valid state, valid data. And this was in block 6. Okay, now let's say block 7 was done, block 8 was done, now we are in the block 15. Okay, now when we attach block 15, what should be my balance? I didn't do any transfer after that. Okay, so when I attach block 15, my balance should be 90, your balance should be 10. If this is different, then that block is invalid. Okay, if this is same, then the block is valid. Okay, so when you attach a new block, when you compare it with the old existing block and the new block, the state should be equal. It should not change anywhere. Okay, if there's a misconception here, if there's some different changes here, then it won't be accepted. Okay, it will be rejected. Okay, that's why all the node are required to keep a copy of the blocks. Okay, that's how we validate it. Okay, by this way, blockchain would guarantee you security. How? Because if you want to hack something, if you want to change the data, you cannot change it in one block. You have to change it in all the block before it, which is impossible. Because once you write something to blockchain, it's immutable. You cannot update it, right? And if you want to update something that was done long ago, you cannot do it at all. That's how blockchain gives you security. Okay, that's how mining and consensus happen, and they check every single thing. Okay, and once this node would compare that new block with their old block and tell you that hey, this is fine, this has no issues, then the consensus would return as approved. Once it is approved, the block will be added to the blockchain, meaning that these nodes will incorporate that block in their system. Okay, if the consensus return as rejected, basically if they reject it, then the node will be dropped. Okay, so let's see how is this mining happens or how this particular block is created. Before going that, do you guys have any questions on mining and consensus? We'll talk about proof of work and proof of stake right now, the consensus approach. But in general, do you guys have any doubts on the consensus and mining? Any doubts? No? Okay. Coming to proof of work, okay, there are a lot of consensus mechanisms. So basically, like proof of work, proof of stake, all these are names of algorithms. So there are algorithms that does this consensus for you in the blockchain, and these are names given to it. Okay, and there are a lot of consensus mechanism out there. The popular one are proof of work and proof of stake. Okay, proof of work. This was initially incorporated in Bitcoin. Even now, it's proof of work. So here you require a lot of computational power. One, what do I mean by lot of computational power here? Meaning that the proof of work in general, how it works is that you'll have like bunch of miners. Let's say 50 to 100 miners. Okay, who are ready to mine the create a new block for you. Okay, so what happens is all these miners will start competing with each other. So whenever there is a transactions appearing on the chain, they have to bundle that. They have to group that into a block. So all these 100 miners start doing it together. They just compete with each other. So what this Bitcoin or chain does is it gives them a puzzle, basically a mathematical puzzle to solve. So what is this mathematical puzzle to solve? Basically, it gives them a number, target difficulty number. Remember the target difficulty number in block, right? It gives them a target difficulty number and gives them a data set. Okay, so what these miners have to do is they have to hash that. They have to combine these things and they have to hash it. Okay, and the resultant hash number should be lesser than the target difficulty number. To find out that, there is no formula. Okay, there is no predefined formula. Okay, like A plus B or something like that. They have to do it manually. They have to brute force it. They have to guess it. And what they guess here is called nonce. Okay, to hash the data set, they use a number called nonce, and this nonce is nowhere defined. It's not defined anywhere. They have to like brute force it, like one, two, three. They have to keep on trying with different numbers. Okay, and whenever they hash it, okay, if the resultant hash, right, if the resultant hash satisfies the criteria of the requirement, then that particular miner would be selected to create a new block. Okay, and this process is so intensive that is all these 100 miners, since they're guessing and brute forcing this particular nonce and trying to find this hash together, it just generates a lot of energy, and then basically it requires when you combine them, the computational power is huge. That's why people keep on complaining, like environmental activists and everything, saying that it's affecting the environment and everything, because these miners are not using their laptop or something. They're using like a data farm or multiple graphic cards and everything to do this, to make this fast. Okay, that's why it generates a lot of energy, a lot of heat and everything, and affects the environment as well. Okay, so that's what happens in proof of work. And once this miner solves it, let's say one miner solves was able to solve this particular puzzle, that particular miner will be selected to group all the transaction occurring for that particular time frame. Basically, in Bitcoin, it's 10 minutes per block. So whatever transaction happens within a 10 minutes, you take the transaction, create a new block. Okay, so this particular miner will do that for you. Okay, and it's not like they are just because they solve the problem, they're legitimate. So what the blockchain does is, or Bitcoin does is, whenever you create that particular block, right, it sends it to the other miners for validation. Okay, so all these other validators who are on the chain, they will validate it. Validation is very simple. You just have to connect with your existing block, check if everything is valid. Okay, it's pretty simple. Creating is hard, validating is very simple. Okay, once validation returns successful, the block will be added to the blockchain, and the miner who did it, he will get a reward. Okay, if it is found out that there is some issue with that particular block, then it will be rejected. Okay, that's how it works. And coming to proof of stake, before proof of stake, recapping proof of work, it requires a lot of computational power, because the miner requires to solve a puzzle, basically a target difficulty problem, and then if they are able to solve it, they get a reward. And here, if you ask me, like, how can I trust a miner who's doing this? They can just play with the blockchain and include some malicious data as well. That doesn't happen because the miner who is willing to mine a block has to invest something as well, meaning that they have to have a good amount of computational resources, which takes a lot of money to purchase and set up. Okay, and then power, they need a lot of power, so it takes a lot of money as well. So if a miner is willing to mine a block for you, they are making hefty investment on the resources. Okay, so if they try to mess with the blockchain, they won't get anything in return. Basically, they're just wasting their money on that. Okay, so validators will prove that, because if the validator prove it's invalid, they'll get reward. So it's competition on both sides. You create a block, you get a reward. You find an issue with the block, you get a reward. So there is no way that people can mess with each other, because they are the one who's losing funds on that. Okay, so you can easily trust the blockchain on this particular concept, on consensus, because it makes sure that everything is a fair game here. It's a win-win situation for both. Okay, coming to proof of stake. So this is one of the another popular consensus mechanism. You might have heard about this when Ethereum transition, right? It was all over. This LinkedIn and then Twitter. So what does proof of stake does? Proof of stake is straightforward. It doesn't require you to solve a puzzle. It doesn't require you to have like a data form or anything. All it does is you have to have 32 ETH. I'm taking a reference of Ethereum here, but the same applies to many blockchains as well. So all you need to have like 32 ETH. 32 ETH is not simple thing. It's a lot of investment, but not compared to proof of work. You don't have to have like you don't have to spend lakhs of rupees on graphic cards and everything. All you have to do is you have to buy 32 ETH, and then you have to stake it. There's a contract on Ethereum's Ethereum chain from Ethereum developers. You have to basically Ethereum Foundation. Sorry, you have to deposit 32 ETH over there, and you'll earn the mining rights. And here you will be selected randomly. It's not like you have to compete with each other. You will be selected randomly to mine a blockchain. So mine a block, okay, and the rest of the time you have to spend your time validating. Okay, if there are 100 of miners who have staked the true ETH and ready to mine a block in proof of stake, so each one will be picked every single time, and the remaining people who were not picked at that particular moment will validate that block, whichever the miner creates. So it's like picking one after the other, giving a chance for everyone, okay, and also making sure that they have their tokens locked, okay, which is their investment to prove legitimacy. And if it found out that the miner is messing with the blockchain, then if it is found out that the validators were able to flag that issue, then the miner who proposed the block will have to pay a penalty. That penalty will be deducted from the 32 ETH he staked. Okay, and the validators who were able to prove that this particular block has an issue will be given a reward. So let's say I was the miner who tried to propose a malicious block, and that was flagged. Okay, and let's say one ETH was deducted from my 32 ETH. Okay, and that one ETH will be redistributed to the validators who proved my block was invalid. Okay, that's how these proof of stake will keep all of these validators and miners happy, as well as properly maintaining the security of the blockchain. Okay, and yeah, before moving to gas fee, do you guys have any questions on proof of work and proof of stake and mining and consensus as well? Any questions, guys? No? All right. Moving to gas fee. So what is gas fee? So gas fee is something like a transaction fee. Okay, so even if you make a transaction on a credit card or debit card, you have to pay a little bit of fee, right, for the convenience fee. It's something like that. The difference is gas fee will help two things. One is the a part of your gas fee will be given to the miner for their hard work. Okay, and the part of the gas fee will help the stability of the price of the token. So in case of Ethereum, you have Ether, ETH, right? So the gas fee will help the miner to get some rewards, and then it also maintains the price. Basically, it stabilizes the price of the Ethereum. Okay, that's the two things. And the way you calculate gas fee is gas limit into gas price per unit. So what happens here is gas fee is used to like allocate basically here computation resources. We'll talk about this in the smart contract part. Okay, but basically what happens is you specify a limit. Basically, you might assume that okay, my transaction might take so and so amount of gas fee. Okay, so you specify a limit, so it should not cross above this limit. So if your transaction takes lesser than your limit, okay, let's say you specified zero point 0.5 ETH as your gas fee. If your transaction takes, let's say, zero point 0.2 ETH, so the remaining zero point 0.3 ETH will be sent back to you. Okay. If it takes more than zero point 0.5 ETH, then your transaction will be aborted. Basically, it will revert back with an error saying that the gas fee exceeded. Okay. And then whatever the zero point 0.5 ETH that you spent will be lost because the blockchain tried to use zero point 0.5 ETH and it was not enough. So you won't get that back. It is just reverted back. Okay. That's how gas fee works. But we'll talk more about this gas fee in smart contracts. Okay, let's move on to Ethereum. So there are a few more slides that we want to discuss about Ethereum blockchain because in the next few sessions we'll be building smart contracts, right? We'll be building a crowdfunding smart contract, and we'll be building that with Ethereum ecosystem. Right now, whatever we discussed here, these were a part of general blockchain fundamentals, which are common in all the blockchains. So now whatever we discuss is regarding Ethereum ecosystem. Okay, any chain that falls in the Ethereum ecosystem will be applied for all of these things like Polygon, Binance, and all of these things. Okay, so what is Ethereum? So Ethereum is a community-run technology. Okay, basically it's a public blockchain. Okay, and it has a cryptocurrency called Ether, with the symbol ETH. Okay, and this was coined by Vitalik. Okay, so since then many people are involved in this development of Ethereum. Okay, and you can learn more about its Ethereum at ethereum.org. They have a lot of amazing documentation on many of the stuff. And coming to smart contracts, so one of the main reason why Ethereum was a really good choice was that, or Ethereum came up with a different idea was that there was Bitcoin initially, which is only used to financial transaction. So you can only transfer funds on Ethereum on Bitcoin. But Ethereum thought that why can't we do something more? Why can't we allow applications to run on blockchain? Okay, and that's where smart contracts came into picture. So smart contracts are just like your code. Like you write JavaScript code, you write Python code, or any code you want, right? It's same thing. Smart contracts, I think, but a simple file with a code that executes itself. Okay, you don't have to have any triggers or anything. Okay, it executes itself on the blockchain. And the thing is, once you deploy a smart contract, you cannot change it again. Okay, whatever the logic you have, you cannot change it. For example, let's say I build a server with Node.js or something, I deploy it, and if I found out there's a bug, I can just go and fix that bug immediately. I can change the logic and fix that bug, right? Or let's say I just deploy a banking backend, okay, and once everything is done, I can just go back and just change the logic to credit all the funds to my account directly. I can just create a backdoor or something like that, right? But that's not possible in smart contract because once you deploy a contract, even if there's a bug or something, you cannot fix it. You have to create a new contract again because it's immutable. Okay, that's why smart contracts are really trustworthy because once you deploy them, you cannot change anything, meaning that community can easily trust, and then they can transfer funds, they can transfer their assets on that. Okay, and then again, it is so secure that it doesn't give you access to anything apart from the functions you write. So let's say you written few functions, that's all you have access for. Okay, and if you define some access, like only owner can access this, only user can access this, only they can access this function. Other than that, nobody else can access that. Okay, you won't get access to file system, you won't get access to memory, you won't get access to process anything. Like in JavaScript or any other low level language, like C or C++, all those stuff, right? We get this file system access, right? We can access files, you can create, delete files, you can access memory, you can create and allocate memory, you can also create process threads, all those stuff, right? You cannot do anything in smart contracts. Okay, it's just that you can run applications on that. You just write application logic on that. That's all. Apart from that, you cannot do anything. Okay, that's why smart contracts are so secure and isolated. Okay, and next thing is smart contracts are compiled. Okay, so when you compile a smart contracts, they turn into bytecode. Okay, and which compiles onto EVM opcode. EVM opcode are something like add, delete, multiply, and stuff like that. Okay, they are like a base assembly language. You guys have heard about assembly language, right? Where we have like a bare bone instructions like add one, add two, delete three, multiply four, something like that. So EVM, whenever you compile a smart contract, at the end they compile down to EVM opcode, which will be executed on the blockchain. Okay, so, and again, we write this smart contracts using a language called Solidity, which we'll be looking into in the next few sessions. Okay, in the tomorrow's and day after tomorrow sessions. And few more things that are important in Ethereum ecosystem. One is wallet. So a blockchain wallet. Okay, you not only Ethereum ecosystem, you take any blockchain, you consider any blockchains, you need a wallet. A wallet is like your bank account. Okay, it lets you hold your crypto assets over there. Okay, if you have any cryptocurrency, you need to have a wallet. Okay, it's like your identity on the blockchain because blockchain is public, right? Anybody can use a blockchain. So since you are a user of the blockchain, you need to have an identity. Okay, this wallet is something that gives you that, and using this particular identity of yours, blockchain will be able to recognize or determine how many funds you actually own in the particular blockchain. Okay, and every wallet in any blockchain has two particular things. One is public key and private key. Public key is something but your address. Okay, you can share that with any friends and any of your friends or anybody outside. Okay, and you can use this public key to get funds as well, send and receive funds. So if I want to send 10 tokens to you, you have to share your public key with me so that I can use that to send 10 tokens to you. Okay, but private key is something that should not be shared in public. Okay, private key is something that are used to generate or create this public key. Okay, and you should not share this private key because if you share your private key with me, I can easily access your funds and I can easily transfer that to myself. Okay, so public key is something should not be shared, and this is common in all the blockchains. And coming to Ethereum accounts, very important accounts. Ethereum has two type of accounts: EOA, externally owned accounts, and then contract accounts. EOA is something like your wallets. Okay, you have public key and private keys in there. Okay, and contract account is something that smart contracts are generated. So whenever you deploy a smart contract, you get a public key in return, which is a contract address. We call that as contract address. Okay, the difference here is contract address doesn't have private key with them. Okay, they cannot do anything. Okay, whereas your wallet, externally owned accounts, has private key. So you can send funds, you can sign a transaction. Main thing, basically you're the one with the private key. So whichever account has a private key can initiate a transaction, meaning that they can put up a transaction on the blockchain. Okay, and they can sign it. Okay, basically any transaction on the blockchain should have a signature. The signature is done by private keys. Okay, if the contract account doesn't have a private key, so they cannot initiate or they cannot put up any transaction on the blockchain. Okay, and these contract accounts are controlled by the code that you write here within Solidity. Okay, that's what Ethereum accounts are. Okay, and with that, that's it for this particular session, guys. Do you have any doubts or any questions? Any doubts or any questions, guys? All right. So if there's no question, okay, there's a question. What is the use of smart contracts on blockchain? As I was talking about that, so if you want to run any applications on blockchain, right? So there was this thought by the Ethereum developers. So why don't we allow many use cases on blockchain? So only transferring financial asset was limited. So if you just transfer tokens back and forth, it's just not worth of a particular entire technology, right? It was just one use case. But why can't we explore something more? Why can't we run applications on that? Like, say, example, these games and everything are using blockchain nowadays, right? So that's what Ethereum developers thought. Why can't we just try to use this particular technology for something more? Okay, that's when smart contract came into picture. So basically, they wanted the trust and immutability of the blockchain to persist, as well as use something that the other technology is using, that are building applications and running on them. They wanted to combine this both. That's why smart contract came into picture. Okay, smart contract will allow your applications to run on the blockchain, as well as keeping the decentralization, the immutability as well intact, there, persistent. Okay, so you get both with smart contracts. Okay, that's why you need smart contracts on blockchain. Okay, great. Any other questions, guys? All right. So in the next sessions, what we'll be doing is we'll be looking into Solidity, basics of smart contracts. Basically, we'll learn about the language which is used to build a smart contract. Okay, so we'll learn about things like basic things like every language has like data types, variables, constant functions, and all this stuff. And then we build this contract called crowdfunding. You guys know what is crowdfunding, right? So basically, you create a project and you anybody can fund that project. Any public people, and you can withdraw the funding as an owner. Okay, and then you can allow people to fund it more if they want. Okay, so we build that and we'll deploy it to Polygon because Ethereum testnet here has some scarcity on the faucet. So we'll deploy it to Polygon, which is also an Ethereum based, EVM based chain as well. Okay, it is a part of Ethereum ecosystem. So we'll use Polygon to deploy it, and then we'll explore some of the things. And before going there, I just wanted to show you this real world transactions part. So let me show you that. Let me share my screen again. So remember in the slide, we did talk about this node. Inside node, you'll have blocks. Inside blocks, you'll have transactions, right? So let's see that how it works. So here I'm in this particular explorer. So this is a Polygon explorer, meaning that this Polygon chain gives you this particular website or this application where you can check all the transaction happening on the blockchain. So basically, these are all the transactions. You can see 25 seconds ago, there were these transactions and everything. You can check any transaction happens on the blockchain. Okay, basically this gives you transparency, so you can check any transaction, what is the funds that people are passing and everything. Okay, and you can see latest blocks. So there are blocks being created. So you can see 26 seconds ago there was a block with 52 transaction on that. So let's go inside this. This inside this block number 43705492 something. Okay, and you know this, right? There are blocks inside blocks. You have bunch of transactions, right? So you can see this particular block. This is the block number that is 4370549 2. Okay, so just imagine what is the how many blocks this polygon has right now. Okay, and you can see this polygon has 52 transaction inside it, right? It has 52 transactions. Basically, 52 transactions were done inside this block, and it was bundled together. Okay, and this was validated by this particular address. So basically, remember the validation that we were talking about, all the mining and validation. So this is the miner who were able to do this. Okay, and this is a reward that was sent to the miner. Okay, zero point 0.7 matic. Matic is the currency of this particular blockchain Polygon. Okay, see, like in Bitcoin you have like BTC, in Ethereum you have like ETH, and then in Polygon it's Matic. Okay, similarly you can see there are a lot of other details like the target difficulty number, and then some gas that was used, and some other data as well. So this is how we explore all these things. We come to the explorer. So you take any blockchain, you'll have an explorer associated with it where you can view your transaction. And this is really useful because let me open up a transaction and show that for you as well. This is the transaction. So you will get many details here, basically whether your transaction was successful or not. Okay, and what is the transaction hash? This is the transaction hash. This is unique for all your transaction. So if you make a transaction today, okay, and after 1 year, if you want to trace back and view the details of that, with this transaction hash you can easily do it. Okay, you can just search this transaction hash here, you will get all the details. Okay, that's how it is interconnected and it is indexed properly. Okay, and you can see the timestamp and all those stuff like who initiated this transaction, and then where this was transaction, basically the from and to address. Okay, and you can see this from is a externally owned accounts, meaning this has a private key behind it who actually signed this particular transaction. And this two is a contract account. You can see this is mentioned as contract here. Basically this is the contract account where the transaction took place, okay, from and to. And the gas fee used here, you can see transaction fee here, it was zero point 0.01 matic. So there was zero point 0.01 matic, meaning in us it's just zero point 0.01 US dollars. Okay, so this is the amount of gas that was used, and there are some more details as well, like what is the input data and all those stuff, like basically what was the data passed as well. So everything is transparent here. Okay, everything is visible to the public, and you can actually view all those details in this particular explorer. And this applies for all the blockchain. We'll have explorer for all the blockchain where you can actually go there and debug your transaction. And let's say your transaction error through some error, it reverted back. You can use the transaction hash to come to this particular explorer and learn more about why your transaction reverted, and if there's any other thing that you want to take care of to make it successful. Okay, all right guys, do you have any more doubts on this particular session? Any questions guys, you can just drop a message in the chat. All right, then. If there's no question, maybe we can end the session here. But I'll see you tomorrow, guys. We'll start working on Solidity, and then we'll write a crowdfunding contract. Okay. Thank you so much for joining, guys. I'll see you tomorrow. Bye.